Hello, Tech Week. Hello, everybody. For me, it's a pleasure to be here as a speaker. Maybe most of people don't know me, but my name is Renan. I was La Salle student of computer science from 2018 to 2020. I have electrical engineering background, but I love software development. And since I finished the college, I got hired for a company in US to be a mobile full stack developer, React Native basically. So was there that I saw GraphQL for the first time, and so uh, I really loved because it's a very powerful tool to use like in software development. And yeah, and today I'm here. It's thank you again, thank you Int, thank you Tech Week, thank you La Salle College, thank you all the sponsors to invited me as a speaker. For the first year, I attended Tech Week as a student. For the second year, I attended Tech Week as a vice president of Int, and now I'm a speaker. So for me, it's a pleasure. And today, I hope I can show you a little piece of how GraphQL works and what's the difference between GraphQL and REST APIs. And we're gonna build uh, a good entire application. It's a very small application, but we'll be able to connect our API with a database, and we can show how it's going to work. So I hope you enjoy. Thank you so much again, and let's go. As I said to you before, today I will talk a little bit about GraphQL and the difference between GraphQL and REST API. And the purpose of this tech talk, by the end, we will be able to create a small API that will be connected with MongoDB. It's a database. We'll connect the API, the GraphQL API with the Mongo in cloud. So it's going to be a very small application, but very useful application also that you can use the knowledge to build bigger APIs in the future. So the first of all, I could start with what's the purpose of GraphQL. A lot of questions that people make is so GraphQL will replace front end, or this is going to replace the back end. But like no, GraphQL it just use the same communication protocol of a REST API, that's the HTTP protocol. However, it creates different rules and on how the information will be transmitted between the backend and the front end. So we will continue to using HTTP requests to communicate front end to backend of the application, but GraphQL has its libraries to make those communications. So what is a REST API? So API, the meaning of API is application programming interface, and the meaning of REST is representational state transfer. So REST API is a communication protocol. It's a communication pattern that uses HTTP protocol to communicate front end and back end. REST API, they use all the functionalities provided by the HTTP protocol. That's a get, post, put, and delete, the HTTP methods. And the client side will use one of those HTTP methods to create a request by sending a JSON, and the API, the REST API, will communicate with the server. That can be a database, and will return the informations that were requested by the client side. You still use the HTTP protocol to communicate. So it's completely the same of the REST API. And so You can ask me, for example, well, Renan, okay, but if I'm going to use the same way to do, what's the benefit of using GraphQL? So, nowadays, I can say that all the applications, or most of them, no matter how small it is, we have several routes in our application. Let's suppose, for example, a user controller in our backend, for example. So, uh, in the REST API case, we need to have, for example, imagine that the user is a student, and in the REST API case, we have the route students. So every time that I need to access the students, I need to use one of the HTTP methods. For example, if I want to return the students, I need to check any data. I need to use the get method. If I need to create any user, I need to use the method post. If I need to edit, change anything in a specific user, I need to use the method put. And if I need to delete, I need to use the method delete, as you saw like in the previous slide. And as you can see, at the GraphQL, we have only one route that it's a post method for the HTTP protocol. As I said, they use the same protocol. But instead of having get, post, put, and delete, we have only post, and most of the times we have the route GraphQL. And GraphQL will create the rules on how you can access the different functionalities of your application. Let me open a notepad or a simple new file. And for example, as I mentioned before, imagine we have the route students. So every time that we need to return the students, I need to use the method get students. For example, if I want to create a student, I need to use post students. If I want to edit a student, I need to use the method put students, and with a specific ID. For example, if I want to delete, is the same thing, students, and by and specific ID, for example. It means that every time we have a functionality in our application, we create routes. These routes will call the controller, and the controller will do what needs to be done. With GraphQL, as I said, we have GraphQL. We have only one single route. That's the post GraphQL. And you can say, okay, but how come? How could I access different routes on my application if I have only one single route? How can I differentiate them? So if you have an experience with API requests, you should remember that when we send a request, we have the body of the request, which is a JSON. In this JSON file, we can send anything we want. So it's from this point that GraphQL starts to make the magic. For example, I can send a JSON to for my route as GraphQL, saying, "Hey, GraphQL, I want all the users." And for example, to do it, I just need to send in my request, for example, a query, all users and users, for example, and this will return all the users. And we can, for example, use at the same request how many queries we want. Let's say that I want to return all the users, for example, and all the admins. Okay, let's say all students, and see students, and also I want to return all teachers, and I can return here all teachers. So as you can see, instead of, for example, using REST API, I could I would need two different requests, and here I can, with one request, do all the job. So what changed for us for GraphQL is that we go from a pattern, that's the REST, that we have a lot of routes, to a single route where we will define that what we want to access at the backend by the request body. Another point for GraphQL is we can easily test what we have done, and because GraphQL doesn't have methods get, post, delete, but we have something similar at the GraphQL side, so that it will differentiate what we want to do with the data in our backend. So basically, we have the query, we have mutation, and we have subscription. So every time that we are searching for information, we want to return information, but we don't want to change the data. We can use the query. The mutation, it's when you need to delete or create or change any information. And subscription, it's a little more advanced, but we use subscription when we for the real time, and because it's already integrated with GraphQL, and so we don't need to use, for example, sock.io or similar tools to work with real time. And it's a very amazing feature from GraphQL. We can make a lot of requests, as you see here. We can request information at the same time, but it's very good, for example, that we can do the same if we have mutation. As I said, mutations when we want to create or delete or change or delete any user. And for example, we can use mutation, but also we can use a query. All users, for example, at the same request. So we can create a user and return all the users at the same time. It will save a lot of data consuming. Something that with the REST API, we could need, for example, 5 requests. We can do only with 1 request in the GraphQL side. So, and I think the main point of GraphQL is that, like, at this moment, we pass more responsibility for the front end. And I think now we are facing a moment that front end, it's getting more responsibility. And because let's say we have an application with a lot of front ends, It's very common. We have an application where we have a web platform, mobile platform, and also a public API for external access for clients. When I worked with LogMe, for example, I worked with a GoToConnect product. It's a mobile and web application to make VoIPs. And so at that moment, we were changing our API that was made in Python to start to use queries, GraphQL. So the application has a single backend providing information for the 3 front ends at the same time. And the most of times, the front end, they have different ways to consume those informations. And for example, at the website, we might need paginations to check how many users we're going to return for that specific page, and which page we are. And also we might need a filter, and paginations and filter, for example, at the mobile side, it might be not interesting because we receive what we request. So we can avoid what we call overfatting. That's when your payload, that's the return of your request, it comes with a lot of useless information. Imagine that for the mobile side, for example, you don't need to return some data, so you're gonna need to filter those data at the front end side. So, but you're gonna transfer a lot of information that you don't need at your client side. So it's a data consuming, it's a memory consuming, CPU consuming. So at this moment, I think like this is the main difference between GraphQL and REST API. And so now that you have a brief idea how it works, we can start the code. NodeJS.org and downloading the last stable version. That's the 16.13.0, and we can install the nodes. You can test if you had the node version by typing at the terminal, and also if you have the npm, that's the node pack manager. So both are installed already. So now we can create create the folder GraphQL, and we can open that using Visual Studio Code. Documents, GraphQL. So once you have your folder and your GraphQL Node.js installed, you can use the terminal. There is a library that's called GraphQL Yoga. You can search online, for example, here, GraphQL Yoga. It wraps a lot of tools that we need to install to use a GraphQL server to create our API with GraphQL. So it's going to make our life a little bit easier. So we can install by using npm I, as you can see here, npm I GraphQL-yoga. So GraphQL-yoga. inside your folder, inside the folder that we created. So this is going to install everything that we need to work with the GraphQL. So the first step, now we have the project created, you have all the node modules. You can check inside the package lock.json, all the packages that we use. So we might see Apollo server, the Express also. So everything that GraphQL, everything that we need to install manually. So with the GraphQL Yoga, we can do automatically. So first step of our application, I will create a new folder that I will call source. And inside the source, I will create a new file called server.js. So once we have already the GraphQL server imported by GraphQL Yoga, we can instantiate GraphQL server require GraphQL Yoga. GraphQL Yoga. So, and now we can create a const server equal to new GraphQL server. And for now, we will leave like that because we're gonna need the other stuff the other two parameters to configure it. And here we can just start the server. So for now, that's all we have. And we're gonna start to create our GraphQL files. So inside source, I will create a new folder that I will call GraphQL. And in GraphQL, as I said, GraphQL is strongly typed. So we have like the types inside the GraphQL, so that we need to define. We can call this schema. So let's say we can create a new file that the extension it's GraphQL, and this is going to be our types. So here in this file schema, it's where you can define all the types for your GraphQL. For example, I can have the type user, and my user, I will define all the properties that my user has. So my user can have an ID. So this ID type in capital is something. It's a GraphQL type, so you can use it, and it's kind of the same thing of the MongoDB that we're gonna use also in this application. When you put exclamation mark, it means that it must have. So you are obligated to have this property for user. So you need to have a name, and we can define an email, for example, and we can say that everything is mandatory. And let's say now that we have a type query, as we mentioned before, that's a GraphQL type is a query. So inside the queries, we will define all the functions, the methods that we will be able to use in our application. So, for example, let's say that we're going to have a query of type users, that will return for me all my users, for example. So I will return an array with all my users. So I must return a user and I must return an array. So for example, by doing that, I'm saying that if I have nothing, I need at least to return an empty array to my client side. And for example, let's say that I can also have a query user that will receive a parameter and will return a user. I cannot have here in this case, for example, the exclamation mark. Why? Because this ID might not be found. So if it's not found, I cannot return a user. So in this case, I don't need to use the exclamation mark because for some events, I might don't have the user to return. And also the mutation, that's the other method that we can use in GraphQL, that we will say, for example, create a user, and the user will have a string name and a string email, and it's going to be mandatory. And also, I will return a user. So every time that I create the user, I'm going to return the user. And for example, in this case, if we validate the create user, we can validate, for example, if the email already exists inside the database. And in this case, we're going to give an error. So we are not obligated also to return a user. So we don't need to put the exclamation mark also. And the second file that we need to configure for GraphQL is the resolvers. That's where you will say what each method that you defined inside your types, inside your schema, what they need to do. So I can create a new file. So new file, resolvers.js. It's not a GraphQL file, it's a JS file. And we can starting by module exports. So, and now we can start by my query, right? And in my query, I have the users that will return for me a function, right? I have my user that will also return for me a function. So this function will do something that we're going to see in the future. And also, let's resolve our mutation. That for now we have only create user, and this will also return a function. So now we have everything almost set up for our GraphQL server. So we only need to take those types and resolvers and add in our GraphQL server. So we need to import them. To import the schema, I will use the path require and path, and I can use type defs. As you can see, it's a param inside the GraphQL server, and path resolve. I'll use a dir name and the directory of the file. It's inside GraphQL /schema.graphql, and comma our resolver. So resolvers. That's I will import here const resolvers equal to require, and I export it inside the GraphQL /resolvers. Semicolon. So for now, we have everything for our resolvers. Okay. So now we have everything for our GraphQL server. So it might work if we run npm source server.js. So we got an error. Okay, resolvers. Okay, so we're missing our resolvers. Okay, now it's fine. So if we run the server, no errors, as you can see, and we can access by localhost 4000. And as you can see, we have the playground here. That's the place where we can test all the queries and the mutation. And for example, the query, we have users. This should return all the users, and here I can define what I need from each user. For example, name. So for now, the user, it's null, so we cannot return it. So to test if what we did so far it's fine, let's create, for example, an array of users. Inside this array of users, you can have the ID, for example, name. I can have my name, and I can have an email, for example, at hotmail.com. So it's an array of users. Let me create another user here. To LaSalle at lasalle.com. So in this case, now we need to check what we're going to return here. For example, for the users, I want to return all the users, for example. And imagine if I want to search only one user. For now, I will not filter anything, but let's say that we're going to return the user 0. Okay, users 0. That's the first. That's me. So as you can see, the format of my user, it's ID, name, and email. That's the same type that I created for the user here. If I finish, if I stop my database, my server, sorry, and I restart it again, I go back to my background, to my playground. Now I have the query user's name. So this is the magic of GraphQL. So imagine that I am like at the client side and I want to access the database, the backend, but I just want to return one single parameter. That's the name. So I will return the name for all the users. But imagine now that instead of only name, imagine in my web application, I need the ID and the name, and you have this returning. But for the, I don't know, for the client API, I want to return everything, and there we go, and we have it. If you want to return only the user, as you can see, okay, I need to send the ID. So ID equals 1, it's going to return anyways always the same, because as you can see here, my query user, I must have an ID. So in here, I'm returning always the first one that you create at the resolver. But okay, so our server is working. Now we don't have any connections with the database, but we'll create now by using MongoDB our database. So to use MongoDB is very simple. You can access mongodb.com, create a free account. I already have it. So I will show you step by step how to create the entire application. And I already have here a GraphQL project that I created, only new project, for example. And let's say Tech Week. And next, and owner, create project. Okay, now you can build a database. You can use the free version. You can choose where you're going to store your database, if it's Google Cloud, Azure, AWS. So, and the place, we are in North America, so I think this one's the best one for us. So we can create the cluster. So it will take you some minutes. While it is creating the cluster, we can advance with the configuration of our database. To use your data, to use the database, we're gonna use this library that's called Mongoose, that gives a good relation between NodeJS and MongoDB. So to install, we can just use this code npm install or I Mongoose. So we can go back to our application. And here we stop the server, npm Mongoose. So we can install all. Okay, so it's already installed. We can go to our server, and the first step, we're gonna import Mongoose by requiring Mongoose. So now we need to connect our database, but for now I still need to wait the cluster to be done to get, and I will show you how we can connect. And for the DB, for the Mongo, we need to create the model. So I will create a new folder inside source that we call database. Inside the folder database, I'll create a new folder that's called models. And here in models, I'll create a new file that I'll call user.js. So in this file, user.js, we can create our database schema, our MongoDB schema. So we can import Mongoose by requiring Mongoose. Now we can say user is schema. That's going to be our schema for the user. And we can use a Mongoose dot schema. And in here, inside we send a dictionary with the definition of our schema. So our user will have a name that will be a string, and email that's going to be a string also. In this case, we don't need to use ID for the Mongoose because the MongoDB creates the ID automatically. So in JavaScript, we use module exports to export what we create here. And model. So we will export as user our variable user schema. So we could, and that's it. So now we have our database schema. We have our database set up here in our server. We just need to wait the cluster to be done. So the cluster is brand new. The cluster is completely done. So we can connect. Now we need to create a username and a password for the database connection. So let's say TechWeek and password. I don't want to use it. I'll put TechWeek 2021 and create database user. And now we can choose the method of connection. So we can connect with our application by the URL, and you see here we can just copy this string connection, and we need to switch our passwords and my first database for the database name and the database password. So we can close. Not now. And inside here, our connection, we can just paste the URL of connection and comma. We need to set use new URL parser as true. It's my password was tech. This is the password, yeah. So my password was TechWeek 2021, and my first database was TechWeek, I think, if I'm not mistaken. So save, and let's try to run our server to check if it will work or not. Well, so far, no errors. We can check our playground if it's working. So our playground is working fine. I think our connection is good with the database. So to check if the connection, oops, the connection was timing out, so the connection is not good. Let's check in our database the connection. Okay, so the problem is because by security, you need to add your current IP address for the MongoDB just to say that it is you that is using the database. So that's my current IP address, and choose connection method. And now it's the same thing. So close. Now that I set up my IP address, it might work. So here, let me refresh. So it looks fine. I hope it doesn't get timeout anymore. And so, yeah, I think it's fine for now. And now we can just start to use our database instead of using the user, the array of user that we created before. So to do it, we need to import the schema that we created for the MongoDB. So this is inside database -models -user. So by doing this, I will take this schema from MongoDB resolvers. So now I can just start to create my response of my requests. So instead of return the users, now I'm gonna return user and find. Find is it's a MongoDB method that I will not go deeper, but it will return all the users. Like by doing this, it's a MongoDB method that will return for you all the users. If you want to find one single user, you can use find by ID. And here we send the ID, as you can see at the schema. But in here, in my resolver, I have anything. So by default, you can just we don't use the first parameter for the request, so you don't need for now. And here you can just break all the parameters that you send in your schema. So by taking the ID here, I can use the ID to at my response of my request. And to create a user, it will be the same. We also use the user and create. That's a MongoDB method also. And in here, we can send name and email. It's mandatory to create a user. As we saw here, our MongoDB schema, it has name and email. So if I go back to my resolvers, my name doesn't exist. Why? Because I need to do the same here. I need to break and take name and email from my request. So let's check the schema. So name and email to create a user, ID to find a user, and return an array of users. So resolver. Okay, my database is running fine. I don't need the users anymore because I'm connected with my database. And let me save, stop the application, and run again if everything is working fine. So we can go to our playground. We can create a query. We can try to find users and return to me ID, for example. And so yeah, it's working fine. It returned to me an empty array because we don't have any user inside our database, our node database. So we can create our first user by using mutation. That's the method for GraphQL that we use to change any data. So we have the method create user that we create here. Create user. That's going to receive a name and email. So as a parameter, as you can see, name, and I'll say Renan, and email that I can say Renan_hotmail.com. And the beauty of GraphQL, we return a user and user. So I can get any information for this user. That's going to be me. I can get ID, for example, and I can get name. So for now, I don't have any ID. So if I press play and our server is working, it should go to the MongoDB here, create the new user. The MongoDB will give an ID for this user, and we will return the ID for our client side. So if I press play, there we go. We have this ID that it's related to my MongoDB. If I refresh, I have the data over here. So it's amazing. So we can do more tests. Also, we can go back to our playground. For example, we can try to add another user. Let's say TechWeek, LaSalle, college.com, and return me. I don't need the name anymore. For example, now I need ID and email as payloads of my request. So, and there we go. We create another user, but for example, imagine that when you create the user from your mobile application, you want to return ID and name, but when you create your user from the web application, you want to return ID and email. So you have the same route, but you describe in your request what you need back. So it's amazing. And if we check the MongoDB side and we refresh, and there we go. We have the two users now. We can go back, for example, to users, and we can check like now if I press play, you see now, for example, I can request the name of all users, and I can take, for example, name and ID for all the users, or I can take name and email. So, and it's very fast, but what's happening? I'm creating a request. It goes to my resolver. It accesses my database and it returns to me all the data. So it's very useful. That's the other function that we have created. That's when we when we want to return a single user. So by the ID, it's a string. We can go to the database and we can take, for example, the ID for the user tech week, and we can paste, and when we play, there we go. And the same, we can control what we need back. For example, we want to send the ID and return only email and name. And this is very good because you can have a very light payload, so you have the best scenario for your request response. So I think that's it. We tested all the resolvers that we created. We tested the returning all the users, returning one user by ID, and also creating user. We didn't do any validation. So for example, if we go back to the playground to create a user, as we can check inside the database, we have two users that we created before. And imagine that I can try to create the same user again. So as you can see, the ID changed. If I do one more time, it keeps changing because I don't have any restriction when I create my my user. So I have the same user with the same email. So at least when we have a real application, we want to each user to have one email because this is a unique. So to make it more real, we can just go to our create user resolver, and we can do just some validations before we create the user. So as you see here, it is a function. So because we return directly a method, a MongoDB method. So we did not use the brackets, but we can use the brackets. And so instead of saving creating the user directly to the database, we're gonna do some validations. So we can create a constant user, and we can use another MongoDB method that's called find one. So in this method, we can send which property we want to find. So in this case, we need to find by email because we need the email to be unique. And we can use the parameter email that we send by the resolver, by the request. So once I have it, I can check if the user exists or not. So for example, I can do return user. So if user exists, return me the user. So don't create a new user inside the database. If not, if the user does not exist, so we can create our user. So by doing that, I don't know if you know this structure for if, but this is the same of create. For example, if user. So if it exists, do something, and else do something else. So this is just to make it a little bit more cleaner, and we can save what we did. we need to stop our database and run again, and we can check if the changes are working fine. So if I try to create a user, it should return me the same ID every time that I try to create. So it returns the ID. So every time that I press, it doesn't work anymore because I'm creating the same. I'm checking if the email exists, and so I'm not creating anymore. So we still have like 4. I can delete, for example, the 2 last, and I can try to create again, and I keep having the same results. If I refresh my database, so I still have just 1. So this is a good validation to do to avoid create the same user several times inside the database. So now that we can create a user with a validation. Let's just to finish. Let's create another mutation that will edit our user, our existing user. So we'll create a new mutation that I'm gonna call this edit user. So this will receive also a name as a string and will be mandatory, and also the email that will be a string and also mandatory, and it will return for me a user also. So not exclamation mark because it might not find the user if it doesn't exist. So I will return nothing if I cannot find a user to edit. So if we go back to resolvers, we need to create a new mutation resolver that will be called edit user also. And in here, the same. So the first parameter we don't need for now. Email and name. So we are breaking the structure to get the parameters. So here a little bit, and we will return the user. Another MongoDB method that we can use to edit. So you can see we have a lot of methods for the MongoDB schema, and for now to edit we use find one and update. So in this method we can pass the first parameter will be which property you want to find to compare in your database. So I will compare by email. So I want to find a user by email, and the second parameter will be which property you want to change inside your database. So I want to change the name, for example, name. And the third parameter, you can set this configuration new as true to say that like I want to return the new. By default, if I don't use the last parameter as I used here, it will return to me the user before before the change. If I set as true, it will return for me the user after the change. So we can try now. Let's save this and also restart the server. And so now we should have a new schema called edit user. One thing that I did not mention, as you can see, we don't need to use the async method in our functions, in our mutations. Even it's a database connection and request, because the GraphQL already understands that like this is an asynchronous request, and it does automatically. And so let's test. Let's go to our playground. So let's create a new mutation, edit user, and name will be email. Let's start with email. So I will edit my user, for example. Let me copy it, paste. The second parameter will be the name that I want to change. So before was Renan, and now I will put my full name, for example. So, and after this, please, I will return the new user. So return me the ID, name, the new name, and the email. So if I play, there we go. So as we can check, the ID here, so 356 is the same. Now I have previously I have my name Renan. If I refresh my database, now I can check Renan Barros. So it worked. So we are able to update a user. Also, if we go to our query users, we can return all the users. So now we have a Renan Barros, and so it's very, very, very fast. For example, if I change here, I go to the users, I change again, it's already done. So it's very powerful. We didn't do any validation to check if the email exists or not. So we can do the same, but now instead of return the same user, for example, let's do something different. So we can just put the brackets. So now we can do the validation before we edit the user. So what I will do now, it's I will do the same check. For example, const user equal to user.find1, and I will check by email and our email. Sorry. So let's take one user and check if the email exists inside the database. And now, instead of do the same thing that we did here at the top, we do something different. So we're gonna throw an error if the user exists, doesn't exist. So if the user, I used a different structure now. So if the user exists, please return, if the user exists, please return to me, this is a little bit messy, this indentation. Let me fix this. Let me put it there. So now we have the if, now we have this. So to clean up a little bit, okay, so that's fine. It's more understandable. And so if the user exists, please find and update by email, update the name, and return me the new user. If the user does not exist, please throw a new error. So user does not exist. And with that, we can try again. For example, rerun the server. Let's go to our edit user. So imagine that I try to edit int at int.com and to name int. Okay, it should throw an error. Let's check what's wrong with our code. Okay, so as I said before, we don't need to use async function here, async method here for the resolvers, because the GraphQL understands that the return is an asynchronous method. But in this case, because we need this answer before we return, I think this is returning before I have the good answer from the defined one. So in this case here before, we should have the same problem sometimes. So we can use an async function also and await. And let's say here async and await. So as you can see, I still don't need the await for the return. Neither here and here. So, but because we need to check this before, yeah, in this case we must have it, because we need to make sure that the flow will just jump for the return when I have the result for this call. So let's restart our server to check if it was a mistake. If we go back and we try, there we go. So now we got an error. User doesn't exist. So our resolver edit user, it is working fine with a validation when I use any email that doesn't exist. So we can try again. For example, now we can try for the LaSalle College email, for example, and now the name before was TechWeek, and now I want to use Tech Week 2021. If I press, so it is working fine. So I want to show you something that's very interesting about the GraphQL is that it provides a schema and a docs. That's a documentation of the API. So we don't need to use any tools, for example, as OpenAPI or Swagger, to create our documentation, because the GraphQL already provides everything. So we have the docs with like all our queries, all of all our mutations, and how it works, the type of the user, what's mandatory to send the request, each type of argument and everything. And in the schema, we have the same, but in a schema structure. So this is amazing. I think this is one of the advantages if we compare the REST API with GraphQL. So finally, I think we saw a lot of things. Yeah, I hope I could have more time, but it should be only a small idea about GraphQL, and just to let you know how powerful is this new way to build the APIs. And I hope you can start to use it in your its projects in the college. And thank you again. Thank you, La Salle College. Thank you, Int. Thank you all the sponsors for Tech Week. And I hope I can see you next year. And it was a very pleasure to be part of this again. Bye.